Hello everyone, this is Alvaro Amigo from the Geological and Mining Survey of Chile. I was asked to give this talk about the Andean subduction zone, in particular from the Chilean perspective. Unfortunately, I was not able to be there with you in person this time. I'm sure the discussion will be very stimulating and interesting in the next days, and I hope that this presentation will somehow help on that. Okay, the first thing that I wanted to show you is this schematic map of South America and the Pacific Oceanic plates. And one thing that is immediately obvious is the convergence rates and directions along the length of the Andes. And we can see here the Nazca plates and the Antarctic plate that has different convergence rates, much smaller than Antarctic plate, and also it's very clear that the direction of the Nazca plate is oblique, and that has some implication on the tectonic behavior in southern Chile. Also, ages of the Nazca plates are shown here near the trench, and from the tripod point here is becoming older and older, and then again younger here in the northern extreme of the Nazca plate. The subduction geometry is indicated by the depth in kilometers here to the Benioff zone. So one can have a first approximation of the geometry of subduction looking these isolines. And also it's shown here 4 volcanic zones where the volcanism is active in South America. The first one is the northern volcanic zone in Colombia and Ecuador, and then flat slab, the segment, the Peruvian flat slab segment is a region where volcanism is recent volcanism, at least in the last few million years, is absent. And then there is the central volcanic zone in southern Peru, northwestern Argentina, Bolivia, northern Chile. And then another flat slab segment, this is called as Pampean flat slab segment, again without recent volcanism. And then from the latitude of Santiago to the south, to the tripod point here, there is this southern volcanic zone that is the most active volcanic region in Chile. Also, there is a magmatic arc related to the subduction of the Antarctic plate beneath South America, and that is known as the Austral volcanic zone here in southernmost Chile. Some facts to have in mind here is that Chile is frequently affected by large tsunamigenic and damaging earthquakes. At least 10 magnitude 8 or larger earthquakes have occurred along the Chilean coast during the 20th century, as you know, including the largest event recorded in 1960. Return periods for a magnitude 8 earthquake are of the order of 80 to 120 years for any given region in Chile, and about a dozen years when the country is considered as a whole. Historical records of local damage, tsunami heights recorded in Japan, and paleoseismological studies have evidenced several earthquakes with magnitude near or exceeding 9. And in recent years, paleoseismological studies carried out in southern Chile indicate recurrence rates of 300 years for large megathrust earthquakes. So several seismogenic zones are recognized in Chile. Here I'm showing this figure where seismicity is defined in the boundaries of the major plates in South America, a bit less defined because of less seismic productivity are the contacts between South America, the South American plates, with the Antarctic plate here, also a region of subduction as we saw in the last slides, and the Scotia plate here, that is this left lateral strike-slip fault. So the first seismogenic zone is the Nazca and South American coupling region, and is where large earthquakes at shallow depths have occurred, and also responsible for most of the damage recorded in the Chilean history. A second seismogenic zone is these intermediate depth earthquakes between 60 and 200 kilometers depth, usually tensional but also compressional events within the subducting Nazca plate. And one important fact to mention here is that the deadliest earthquake in Chilean history occurred in 1939. This 7.8 earthquake that produced more than 20,000 fatalities in the city of Chillán. Most of the fatalities are people that live there in Chillán. This is a city in the central south part of Chile, around 400 kilometers south of Santiago, 100 kilometers to the east to Concepción. That's another important city in southern Chile. And a third seismogenic zone is this shallow seismicity within the overriding plates related to different factors. One is shallow depths in the Andean Cordillera, and this is an example of the magnitude 6.9 event in 1958 that occurs not far from Santiago in the Andes Cordillera that trigger significant number of landslides. Crustal faults as consequence of the oblique convergence of the Nazca plate, such as the Liquiñe-Ofqui fault zone, and this fault extend from here, from the triple point to 1,000 kilometers to the north, and that's very important tectonic feature in southern Chile. And finally, the southern extreme of the continent is tectonically dominated by the Magallanes-Fañano fault system that is around there. That is a left lateral strike-slip fault due to the relative horizontal displacement of the Scotia and South American plates. And a couple of earthquakes were registered in 1949 and produced a lot of damage around Punta Arenas, that is the southernmost city of Chile. And finally, a fourth seismogenic zone is related to deeper seismicity that occurs further to the east, up to 650 kilometers depth beneath Bolivia and northwestern Argentina, in that particular region. So now I want to show you more detail of this seismicity according to latitude. The important thing here is the color bar is related to the depth of the epicenters according to this scale here. And also note that the purple lines are the estimated rupture extent, these ones, of giant earthquakes occurred in the last centuries, whereas the yellow lines here are related to the rupture length of smaller events that rupture a partial zone of the interplate contact. Also, the black stars here, Tarapacá in 2005 and Calama in 1950, indicate the epicenters of major intraplate intermediate depth events. And on the right-hand side, from the seismological center, we can see different profiles here near Arica, this region there, and this one here a bit south that shows this deeper seismicity. The profiles show the depth distribution of earthquakes as a function of distance from the trench, this axis here. So this is the northern and north-central Chilean seismicity, and then the north-central and central seismicity. Here is located Santiago, where most of the population live in Chile. Also, it's located here, the 1730 giant earthquake here, rupture zone, and the recent 2010 8.8 Maule earthquake there. And here again, the star is this intraplate event that is the one that we mentioned before, that is the deadliest earthquake occurred in the Chilean history. And a couple of profiles that shows here the difference between the two regions. And finally, this is the south central seismicity up to the triple point here, only seismicity related to the Nazca plates, not Antarctic plates. And you can see again this giant rupture zone that is the 1960 event. Okay, now in terms of volcanism, I'm showing here the last explosive events in southern Chile. I'm not including activity from the central volcanic zone in northern Chile because the southern volcanic zone is the most active segment in Chile. And these are the last events. I also include here the volume in terms of cubic kilometers and the compositions, and you can see that there is a wide range of compositions in the activity during the last years, including these rhyolites. 75% of silica rhyolites injected in 2008. And then Hudson in northern Patagonia is the largest event in the last decades. This was a plenary eruption with 5 cubic kilometers and an eruptive column of more than 20 kilometers high, and also was characterized by two type of products, one andesitic and the other one basaltic. So it was a very interesting dynamics. But when we start to see eruptions back in time, such as Kizapu in 1932, this volcano is located in central Chile, 200 to 300 kilometers south of Santiago, the capital. We found these events of 10 cubic kilometer, in this case acidic in composition, and this one was a proper large Plinian event that lasts for less than 1 day and a column height of more than 30 kilometers. And that obviously produced a big impact in the southern part of South America, mostly related to ashfall. And when we see explosive events in tens of thousands years, so this kind of events are evident, such as the Caldera Diamante and Maipo volcano here not far from Santiago, again in the capital of Chile, where it's possible to recognize deposits from these PVCs related to the caldera forming eruption occur 130 kiloyears BP. And again, this the composition of this large event is rhyolite. So we have more frequent activity, andesitic, basaltic andesite, and then in terms of tens or centuries, the acidic eruptions are more common, larger in size, and then rhyolitic large events. Also, I would like to mention here that this in the southern volcanic zone there is a project now led by the University of Wisconsin that is the generation of high-resolution records of cone growth, eruptive behavior, erosion, and geochemical evolution from 200,000 years to the present. And essentially, this project is trying to establish the impact of the glaciation on volcanic activity and productivity and magmatic productivity. So I think it's a good thing to have in mind, this project that is ongoing. And another interesting thing to mention is that this Austral volcanic zone is I think is basically unknown for us. But some tephrochronological studies, in particular the recent study of Smith in 2019, look here at the Potok Aike Lake in Argentina, and was able to recognize several explosive events in the last 1,000 years, and most of them from this volcano, Bernie volcano, but we don't know much about that, and we don't have instruments yet in that region. So in terms of early warning, Magallanes for us is a big priority. And finally, in terms of landscape and seascapes, the first figure here is to show you the climate distribution in Chile, because it's so long. Chile has this opportunity that goes from dry, arid climate in northern Chile, and then semi-arid Mediterranean in the central part of Chile, and then polar oceanic with very high rainfall records. And then in the southernmost Chile is a tundra type of climate. So obviously the north-south relationship here with the climate is very important, from very arid to wet, but also west to east in terms of the coastal range, central depression, and the main range. At least here up to the Lake District. Then this region here is the Fjordland, so it's a little bit different, the configuration. And another thing that is important here is that climate change is impacting the geohazards here in Chile, increasing the frequency and magnitude of rapid events such as landslides and debris flow. So we have observed that in the last years. Here are some examples of earthquakes and tsunamis. I wanted to show you also liquefaction is something that usually happens after the big earthquakes. And this is a nice example of earthquake triggered by seismic activity, but this is not related to the large megathrust events. This is the crustal activity of the Likiniovki fault, and this is the Isen fjord that produced landslides and tsunamis in the fjord. This was an event in 2007. And of course, landslide and debris flows on rock falls, and this one in 2015 was particularly very large impact in northern Chile, destroying practically a city.